All right, so here you want to work through some examples using postulates, definitions, vocab words, theorems, all about angles. So you can see in example 1 here, we have a couple different givens. So what I'm going to do is I'm going to go through each one individually and mark up the diagram with what it tells us. So our first given says that ray BD bisects angle ABC. Okay, so in order to know what that means, we need to know the vocab. Hopefully you remember that bisect means to cut into 2 equal pieces. So that means ray BD is bisecting angle ABC, which means I can mark angle ABD congruent to angle DBC. So what I'm going to do is put that in my proof right away before I forget what I did. So I'm going to color code this so we know what is coming from what. So statement number 1 is that ray BD bisects angle ABC. And we knew that because it was given. So we took that word bisect and we defined it. So reason number 2 is going to be definition of bisect. Anytime you have a vocab word in your given, you're going to go ahead and say what that means. So because of that word, we said that angle ABD was congruent to angle DBC. Okay, so that's all from that first piece of the given. We switch colors here. Now we're going to look at the second piece of the given. So the second piece of the given says that ray CA bisects angle DCB. So that means that angle DCA and angle ACB have to be congruent. So again, I'm going to copy my given over. Ray CA bisects angle DCB. How did we know that? Well, that was given to us. And again, that vocab word bisect was in the given, so I'm going to define that. And my statement is the same thing that we were just able to mark because of that. We were able, we were able to mark that angle DCA was congruent to angle ACB. I'm going to switch colors again and look at our last given. So here we're told that angle ABD is congruent to DCA. So ABD, so I'm going to give that 3 arcs, and angle DCA, I'm going to give that 3 arcs. I'm going to go ahead and put that over here in my proof. Angle ABD is congruent to angle DCA. And how did we know that? Well, that was given to us. All right, so now our ultimate goal looks like we're trying to show that angle DBC is congruent to angle ACB. So I'm going to look in my proof and see where I already have these names. So angle DBC I have here, and angle ACB I have here. Well, if I look at what that's congruent to, in statement 2, we're told that angle DBC is congruent to angle ABD. Well, if I look down here at statement 5, I have angle ABD right here, congruent to angle DCA. And if I look here, I have angle DCA in statement 4 as well, being congruent to ACB. So if we use the transitive property, we can eliminate all of this repeated information. So angle ABD is repeated, I'm going to eliminate that. Angle DCA is repeated, I'm going to eliminate that. So actually what I'm left with when I eliminate all of my repeated information is that angle DBC is congruent to angle ACB. We did that by eliminating all of that repeated information. So that's our transitive property of equality. And this statement right here at the end does indeed match your proof statement, which means your proof is done. For example 2 here, I'm going to do the same thing. I'm going to go through each piece of my given and then say what that means. So this first piece of the given says angle 1 and angle 2 are complementary. Well, we need to know the vocab. Complementary means that it adds up to 90 degrees, which means 1 and 2 together form a right angle. So I'm going to put that box into my diagram. And I'm going to bring my statements down. So when you write the given, it's got to look exactly like it's given to you. You might be able to abbreviate some things, but it's got to be the same exact statement. So angle 1 and angle 2 are complementary. I'm going to abbreviate complementary to be comp. Okay, and that was given information. So then what that means, I need to put a box in there. So that means the measure of angle 1 plus the measure of angle 2 equals 90 degrees. And again, we knew that because we're just defining that vocab word. That's definition of complementary. So anytime there is a vocab word in that given, you're going to define it. All right, the second part of my given says that angle 3 and angle 4 are complementary. Again, we have to know what complementary means. That means it adds up to 90. So I'm going to put a box in that part of the diagram. So again, the given gets copied exactly like it's given to you. Oops, sorry, this isn't angle 1, this is angle 3 and angle 4 are complementary. Again, I'm going to abbreviate it. That's totally okay. That was a given piece of information. And then we wrote what that meant. That meant that the measure of angle 3 plus the measure of angle 4 equals 90 degrees. And again, that's by definition of complementary. I don't know what just happened to my pen. Complementary. Now we have some more given information, so I'm going to go ahead and add that into my proof. I'm told the measure of angle 2 equals 24. And I'm told the measure of angle 4 equals 24. And again, our reason there is going to be given because that information was given to us at the beginning of the proof. Given. I'm also going to mark that in my diagram so I know this angle right here is 24 degrees and this angle right here is 24 degrees. Okay. Now, anytime you have two things that are said to be equal, for example, measure of angle 2 is equal to 24, you can substitute that in. So I'm going to go ahead and I'm going to make a new statement here. And wherever there was an angle, measure of angle 2, I'm going to plug in 24 degrees. And what allows me to plug in equivalent values is your substitution property of equality. I'm going to go ahead and do the same thing for the measure of angle 4. Okay, so for statement 7, we'll say the measure of angle 3 plus 24 degrees equals 90 degrees. And again, our reason would be substitution property of equality because you're just taking two equivalent things and substituting them for one another. All right, so now from statement 6, we can solve this for the measure of angle 1. Okay, so if I subtract 24 from both sides, I'm going to get 66 degrees. And what allowed me to do that was subtraction property of equality because I just subtracted 24 from both sides. I can do the same thing from statement 7. Subtract 24 from both sides and I get the measure of angle 3 equals 66 degrees. And again, that would be your subtraction property of equality. Well, now we have some other things going on here. So they're both equal to 66. So I'm going to go ahead and instead of rewriting that 66, I'm going to say the measure of angle 1 equals the measure of angle 3. That could be substitution property of equality. Some people could argue that that's transitive property, but you're really only making one replacement, so I would stick with substitution there. And then if we know that two angles are equal to each other, we can go ahead and say that they are congruent. And that's just definition of congruent. The definition of congruent says that they have the same measure, that they are equal. Well, if we scroll back up here to our proof statement, we can see we were asked to prove angle 1 congruent to angle 3, which is what we have now. So our proof is done. Now this one was a little bit longer. There's 11 steps. You could definitely combine some of these. So for example, statements 1 and 3 we could put as one statement. and one reason as given. And then statements 2 and 4 we could put as one statement, one reason as definition of complementary. But until we get used to proofs, it's a little bit easier if we kind of break it up here. For this example, I'm going to go ahead and do the same thing. I'm going to take a look at whatever is given. Angle 2 is congruent to angle 3. I'm going to mark that on my diagram. So anytime you have angles congruent, you use arcs to show that. And I'm going to put that statement into my proof. So angle 2 is congruent to angle 3. How do we know that? Well, that was given to us. It's right next to the word given. Now our ultimate goal is to get angle 1 congruent to angle 4. That is what we're being asked to prove. So in order to do that, I need to get angle 1 into my proof somehow. So I noticed on my diagram here that 1 and 2 are vertical angles, which means that they have to be congruent. So I'm going to add a single arc into angle 1, and I'm going to put that in my proof. Angle 1 is congruent to angle 2. Well, how do we know that? They're vertical angles, so that's just definition of vertical angles. I can do something very similar to get angle 4 into the proof. Angle 3 and angle 4 are vertical angles because they are right across from one another. So let me go ahead and put that arc on there, and I'm going to get that into my proof. So statement 3, I'm going to say angle 3 is congruent to angle 4. And again, we knew that by definition of vertical angles. All right, now if I look at this, we might notice that we have some repetition going on. I have an angle 2 here and an angle 2 here. So because that's repeated, remember, we can eliminate that. I have angle 3 here, and I have angle 3 here. So because that's repeated, we can eliminate that. So what we do then is we combine all these statements down, and looking at what's left, we're left with angle 1. We eliminated angle 2, we eliminated angle 3, congruent to angle 4. And what allows us to do that is your transitive property of equality. And that's matches right here, matches your proof statement, so you are done that proof.